Okay, so let's go over chapter 3. And what I really want you to pick up from this when we're talking about the distribution. If we have, and I'm just going to label it F here, this is just frequency or the number 1, 2, 3, 4, 5, etc. A normal distribution looks like this, meaning that it's unimodal. Uni just means one. So there's basically one peak, right? Also, with the normal distribution, the main, median, and mode will all be the same piece here. So the mean, x bar, the median, and the mode are all slap dab in the middle. Not to be confused with something where bimodal. Bimodal just means that there'll be two peaks. So for example, if I gave the exam and I had a group of students who did very well and poorly, let's say here, and this is F, just my number of people. Let's say I had a whole bunch of, this would never happen, let's say I had a whole bunch of 70s, people who made a 70, and then the same number of people made 90. Right? This would be considered bimodal. Simply because there are two peaks. Alright, sometimes you can get data that is skewed though, and so the book references this. You can sometimes have it positively skewed or negatively skewed. And when it is positively skewed, let me give you an example of the positively skewed first. Positively skewed just simply means that you're going to find your mode is going to be less than your mean. If you think about it like this, and we've sort of already talked about this before, but if this is your mode, right, you'll find your x bar down here. And the reason being is simply because there's something we would call an outlier. And the outlier just simply means that there's some number way out here, 1,000, that's dragging the mean up. If you kind of think about it, which is why when we're talking about whether you have nominal data, ordinal data, or interval data, which is the best measurement to use, when you're using ordinal data, or not, let me say nominal, probably the appropriate measure of central tendency is going to be the mode. Because with nominal data, remember it's just categories. So if, for example, I knew how many freshmen, sophomores, juniors, and seniors there are in the class. If I know that there are 3 freshmen, 2 sophomores, 7 juniors, and let's say 14 seniors on this one, I probably just want to use the mode. And so I would say, oh, there are more seniors, because that's kind of like the peak, what our histogram would look like. I can't actually get, if you notice this, I can't get what x bar is. I'm not going to get a fair sense simply because we are using these different categories. And while they're ordinal, they kind of give us some information. It's not necessarily a clear method to do it. Alright? The median, you want to use the median preferably when you're dealing with ordinal data, and simply because you can't get the averages as well. And the reason you want to use the median, if you think about it, let's just use numbers. The formula for the median is n plus 1 over 2, right? Because all you're trying to do is find out where's that halfway mark in a list of numbers. N, remember, is nothing more than the number of units in my subset. So if I have a subset, and let's say I've got 1, 2, 4, 7, and 10. This is my subset. I could average them to get the mean, or I could just simply find what the median is. Like, what is the number in the middle? So if I take my n, here my n is 1, 2, 3, 4, 5. N is equal to 5. My median is equal to 5 plus 1 divided by 2, which is 6 over 2, which is equal to 3. I would just simply find out where's the third position. Not what the, so 1, 2, 3. My median is right in the middle, which is going to be 4. However, the reason you want to use median in this situation is because if I were using the average or mean, I would remember sum up 1, 2, 4, 7, 10, and divide by 5. However, if I were to change this subset and put 100 here, my x bar would be very different than my x bar 1. So let's just do this. My x bar 1 would be if I use a 10 here, right? If I use a 10 there, the sum of my x's is going to be equal to, let me get this out, I'm going to have 10 plus 7 plus 4 plus 2 plus 1, 24. My sum of x is going to be equal to 24. And if I do it the other way, with x2 of the 100, my sum of x is just going to be equal to 114. Here, my x bar is going to be equal to my meaning 24 divided by 5, 4.8, 24 divided by 5. Alright, here my x bar is going to be 114 divided by 5, which will be 22.8. So in this example, we would see that our outlier, the 100, caused the data to be positively skewed to the right, all right? And sometimes you'll hear people refer to it as that. And the way that graphically that looks to be positively skewed is where you're going to find the mean much higher, or higher, let me just say greater than, my x bar here is to the right of my mode and my, let's say this would be my median. Half the scores are above, half are below. This is an example of positively skewed distribution. Unlike negatively skewed distribution. In a negatively skewed distribution, you just kind of have to remember, where is the x bar in relation to the median and the mode? And when the x bar is less than the median and the mode, this is considered negatively skewed. And it's just simply going to look like, this is my f here, where this is my mode, here's my x bar, and this is my median, just meaning that the x bar is being dragged down by some number. For example, like when I give the exam, I'll give a couple of exams and I'll tell you what the average is on the exam, the mean. I will often tell you I have thrown out the zeros. So if we have a bunch of grades and then I have 3 zeros at the bottom, I often will just ignore those zeros so I can find out what is the average, and the average isn't being drugged down by someone who was intending on dropping the exam anyway. So that's just the definition of mean, median, and mode.